Hey everybody, welcome to 7.4. New video. I think that I can hopefully make this a little more efficient for you. So we've been talking a lot about logarithms and evaluating them, but today we're going to talk about different properties of logarithms. So our goal is to use those properties and put them together and pull them apart. Now logarithms and exponents have corresponding properties, meaning like very similar properties, right? Because remember, logarithms equal exponents. Like if you do log base 2 of 32, your answer is 5 because 5 is the exponent of 2. Whoops, I meant 32 here, not 35, sorry. Because 5 is the exponent of 2 to get to 32. So they're going to have similar qualities. So we're going to talk first about the product property, then the quotient property, and then the power property. Now, if you remember, when we had like x squared times x to the fourth, you added those exponents to get x to the sixth. That's because if you had a multiplication problem, you added the exponents. So that's what they mean by they're similar to exponent problems. Let's take a look at this one. If you had x4 divided by x2 in chapter 6, you would subtract those and get x to the second. So if you had a division problem, you ended up subtracting your exponents. Last, if you had x to the fourth to the second power, you would multiply those to get x to the eighth. That's why when something inside a logarithm is being raised to another power, you multiply it out front. So it's almost like the n comes out front, but it's because it becomes a multiplication problem, just like this one was a multiplication problem. Now all of that is like math language. So let's state it very simply. If you have a multiplication inside the logarithm, you add two separate logarithms together when you expand them. So single log expanded. If you have division inside your logarithm, when you expand them using subtraction. And if you have an exponent or a power inside the logarithm, you make it a multiplication problem when you expand it. It doesn't really look that expanded, but it is technically. Please remember the bases, so the number in the bottom, must match, at least for today, okay? Part 1, let's practice taking separate logarithms and make them into a single logarithms. I'll have numbers and variables in these problems. Here's your expanded form. Now, there's a lot going on. I chose like 3 very difficult problems because I thought to myself, let's just kind of get it over with and then we'll break it down easier if needed be. Just come see me in the morning or even during class. So let's acknowledge same base. Next, I see a subtraction and a subtraction sign. So I will have some division that's going to be happening. I see a number in the front. Separating these, there's a lot to take in. All right, so I am going to write my single log. Here it is. It's going to have a base of 3. This 2, I'm going to color it green. This 2 needs to become an exponent on that logarithm. So when I put it over here as a single logarithm, 4x to the third is going to need to be squared because of this 2 that was out front. Now I'm going to go to the second log. This minus sign means that this 3y will go in the denominator because it means division. So I'm going to go denominator 3y. And now I'm going to go to my next log. I see another minus sign. So that means, again, this 4 is going to be a division problem. So the 4 is also going to go in the denominator. I'll use parentheses so I don't get too terribly confused because sometimes it looks like 34, but it's 3. It will be 3 times 4. Simplified, that's going to be log base 3. Let's see, 4 squared is 16. X to the third 2 times is actually x to the sixth, 3 times 2. And 3 times 4 is 12 with a y left over. Oh, there is one more step because I always need to look and see if I can reduce using my chapter 6 skills. So log base 3, 16 over 12, let's see, 4 goes into both of those. You can math enter it. It's going to be 4 over 3 when it's done. And we're going to have x6 and y on the bottom. So I had a couple of, I had to write it 3 times for it to make sense, but the long and the short of it is you kind of figure out what goes on the top, what goes on the bottom, kind of simplify them and reduce. Let's try again with another fairly challenging problem. So this 2, I don't like where it's written. I'm going to put it in front of this logarithm and in front of this logarithm, okay? So I'm going to erase all my crazy arrows, change my color. I'm going to distribute my 2 in. So I have a 2 right here and a 2 right here. That's going to help me in the long run. So now I can treat it kind of like I don't have parentheses. All right, let's see. I have this logarithm, I have this logarithm, and then that logarithm. Okay, so they all have a base. Ooh, sneaky. This one has a base of 3. This one has a base of 2. That was sneaky that they didn't have the same bases. And this one has a base of 2. So we should probably acknowledge that that first one had a base of 3. It's going to kind of be a loner. It's going to be on its own because it had the base of 3 versus the other ones that had a base of 2. All right, so let's talk about the first one. This 2 needs to become an exponent on the 5. So my first one's going to be log with a base of 3 of 5 with an exponent of 2. Now, these 2 are going to become one logarithm with a base of 2. So I'm going to highlight those in purple. Over here, here's my single log. Oh, okay, let's see. So that 2 is going to go up to the 3y. But you see that minus sign in front of it? Well, this is kind of a hard one to go to here. That minus sign means it's a division problem. So I'm actually going to have to put 3y squared on the bottom. So take a look. Since it followed a minus sign, my information needs to go in the denominator with my base of 2. I'm going to separate that so it doesn't look like it's 2 times. Okay, let's just restate that. Okay, I'm not sure everybody caught that. Because this was a minus sign, it's a division problem. So that's why I put my 3y squared on the bottom. Might want to rewind that if you need to take a look. All right, let's deal with this pesky 1/2. 1/2 is a power on this parenthesis. So it goes up here. And that's a positive, so that means it's going to go in the numerator. That's how I see it. Positives go in the numerator, negatives in the denominator. So I'm going to put my 9h squared up here. And that was to the 1/2 power because of the 1/2 that was in the front. Now it's time for me to kind of put my plus sign here and simplify. Well, the first one simplified, this one right here, I'll just duplicate it real quick. I know that 5 squared is really 25. This one's all done. This one simplified is going to be a little bit more of a challenge, so let's just go slowly. We're going to also have to draw upon your chapter 6 skills here. Do you remember that a power of 1/2, hopefully, hoping you remember, actually means square root? Well, where does the square root of 9? 3. What is the square root of h squared? H. So that's 3h. Please rewind that if you need to see that happen again. Now in the denominator, I'm going to have to apply my squared. So instead of having 3 squared, I'm going to make it 9. And instead of having y to the power, I'm going to have like y squared. So I had 3 squared, which is 9, and then y squared. Please rewind the video and watch again if you need to. That is almost done. See this 3 and this 9? What is 3 over 9? In fact, you know what I'm going to do is I'm going to duplicate that and just do it again because I'm scared that if I erase it here and you try to study it, you won't know what happened. So 3 divided by 9 is really just 1/3. So there's the ugly final answer. Not all problems will be that difficult, but like I thought, let's get some that have a whole bunch going on, and then hopefully when you get the homework, it's a little more simple. So this 2 is out in front. It's going to go on this y. 2. Okay, this minus sign is going to get distributed. I'll rewrite it because I feel like maybe it's overwhelming if I don't. So here, I'll rewrite it. There's my new minus sign on that because I'm distributing the negative. So guys, I did boom, And boom, pause the video if you're not keeping up, please. And both of these are minus signs. So also please notice they all have a base of 4. So they can all become one single log at the end. So here's my single log with a base of 4. All right. So this one's going to be first and it's positive, so it's going to go in the numerator. So I'm going to put y squared in the numerator. Let's go take a look at what else. Ooh, this one is negative, so it's going to go in the denominator. And there's no, oh, there's an x here, huh? That x is going to be an exponent on the 4. So I'm going to put 4 to the x in the denominator. All right, one more. This is also going to go in the denominator because it's negative, and that 3 is going to go on top of to the x. So I'm going to have x to the third in the denominator. Ew, that's a really gross problem. There's nothing that can get simplified. Like 4 to the x is just 4 to the x. X to the third is just x to the third. Nothing cancels, nothing reduces. So this is the answer. All right, again, they will not all be that difficult. Now we're going to expand some logarithms. So I'm going to give them to you in single form. In fact, you know what I'm going to do? I'm going to make this a new video because maybe you need to take a break and come back.